Scene script. Have you ever wondered how everything began, how the universe, with all its stars and galaxies, came into existence? Welcome to the exploration of the universe's biggest mystery, the origin of all that exists. It's a question that has puzzled humankind since the dawn of our consciousness. From the earliest stargazers to today's most brilliant astrophysicists, the quest to understand where we came from is a journey that has captivated us for millennia. Picture the universe, a vast cosmic ocean filled with galaxies, stars, planets, and all sorts of mysterious matter. Now imagine that all of these, every single iota of matter and space, once fit into an area smaller than the head of a pin. Sounds impossible, doesn't it? Yet this is the astounding proposition put forth by the Big Bang Theory, the most widely accepted scientific explanation for the origin of the universe. The Big Bang Theory suggests that around 14 billion years ago, the universe sprang into existence from a state of incredible density and infinite heat. But it didn't just spring up out of nowhere. The universe, it is believed, expanded rapidly from this hot, dense state into the vast and much cooler cosmos we observe today. While the Big Bang Theory provides a compelling model of the universe's birth, it's not without its mysteries. Like an intricate puzzle, there are pieces that don't quite fit, questions that remain unanswered. For instance, what sparked the Big Bang? What existed before it? These questions continue to stir the minds of scientists, making the origin of the universe one of the greatest mysteries of our time. But fear not, for the curtain is slowly being lifted. As we delve deeper into the cosmic abyss, the secrets of our universe's past are beginning to reveal themselves. The universe, in all its mystifying grandeur, is an open book, and we are just beginning to turn the pages. Now prepare yourself for a journey back to the starting point of everything. Imagine an infinitesimal point, smaller than an atom, containing all the matter and energy of the universe. This isn't the premise of a science fiction novel, but rather the foundation of the Big Bang Theory. In the beginning, and we're talking some 13.8 billion years ago, there was nothing but a singularity. A point of infinite density and temperature where our current understanding of physics breaks down. This singularity, existing in the void of nothingness, was our universe in its earliest form, and is what we refer to when we speak of the Big Bang. But let's clear a common misconception. The Big Bang wasn't an explosion in the traditional sense. It was not matter, and energy bursting out into pre-existing space. No, the Big Bang was an expansion of space itself. It was the moment when the universe started to stretch and grow, from that singularity, smaller than an atom, to the unfathomably large cosmos we are part of today. In a fraction of a second, faster than you can snap your fingers, this singularity began to expand rapidly. This period of rapid expansion is known as inflation. It's during this inflationary period that the seeds for everything in our universe were sown. The fundamental forces we know today, gravity, electromagnetism, and the nuclear forces, began to separate and behave as distinct entities. And as the universe continued to cool and expand, the energy and matter within it began to interact in complex ways, leading to the formation of particles, atoms, and eventually, stars and galaxies. But we're getting ahead of ourselves. That's a tale for another scene. So, the Big Bang Theory is not just about an explosion or a beginning. It's about the birth of time and space. It's about the transformation from a state of unimaginable heat and density to a universe filled with galaxies, stars, planets, and yes, even us. From this violent explosion, the universe as we know it started to form. And that, my friends, is the grand and awe-inspiring story of the Big Bang. In the first seconds following the Big Bang, the universe was unimaginably hot and dense. It was a state of existence so extreme, so utterly alien to our present-day universe, that it's hard to even wrap our minds around it. Picture a reality where all the matter that now forms countless galaxies was compressed into a space smaller than a single atom. As incomprehensible as this may sound, it's from these intense conditions that everything we know, and are, sprang forth. In those first fractions of a second, the universe began to cool and expand. As it did, the fundamental forces of nature that we recognize today, gravity, electromagnetism, and the strong and weak nuclear forces, began to take shape. But it wasn't just the forces that were forming. The particles that would go on to build all the matter in the universe were also being created. As the universe continued to expand and cool, protons and neutrons, the building blocks of atomic nuclei, began to form. These particles born from energy in a process described by Einstein's famous equation, EMC squared, started to dominate the universe. But the universe was still too hot for these particles to combine and form atoms. It was a seething soup of free protons, neutrons, and electrons, zipping around at incredible speeds. As the universe continued to cool, however, things began to change. Protons and neutrons started to come together, forming the nuclei of the simplest elements, hydrogen and helium. The free electrons, still too energetic to be captured by these nuclei, continued to zoom around. But as the universe kept cooling, they too began to slow down. Eventually they were captured by the attractive pull of the positively charged nuclei, forming the first atoms. This was a pivotal moment in the history of the universe. It was the birth of matter as we know it. As the universe continued to cool and expand, the stage was set for the formation of the first stars. It was from these humble beginnings that everything, from galaxies to planets, from life to love, began. From the primordial soup of hydrogen and helium, the first stars were born. Picture this, a colossal cosmic ocean teeming with these two lightest elements. Gravity, the ever-present cosmic sculptor, began its grand masterpiece. In these early moments, gravity was the puppeteer, tugging at the loose ends of this elemental soup. The atoms of hydrogen and helium felt the call of gravity and began to cluster, forming pockets of dense matter. As these pockets grew larger and denser, the pressure at their cores increased, setting the stage for a miraculous transformation. Enter the process known as nuclear fusion. This is the heart of a star, where the intense pressure and temperature force hydrogen atoms to combine and form helium. This process releases an enormous amount of energy, causing the star to glow brightly. The birth of a star is not a solitary event, but a symphony of countless such transformations. But what about galaxies? How do they fit into this cosmic tableau? Well, stars are social creatures. They don't like to exist in isolation. As more and more stars ignited, they began to gravitate towards each other, forming vast, swirling collectives. These are what we call galaxies. Our own galaxy, the Milky Way, is a testament to this cosmic dance. It's a swirling whirlpool of approximately 200 billion stars, all bound together by gravity. And this is just one galaxy among countless others. Current estimates suggest that there may be as many as 2 trillion galaxies in the observable universe, each with its own myriad of stars. Isn't it mind-boggling to think that all this grandeur, this vast cosmic spectacle, originated from a soup of hydrogen and helium? It's a testament to the power of gravity and the fundamental forces of nature. So, from a point smaller than an atom, the universe has expanded into a vast expanse filled with galaxies, stars, and planets. And we, on our tiny blue dot, are privileged to be a part of this awe-inspiring cosmic journey. What a journey it's been, from the Big Bang to the formation of stars and galaxies. As we trace back the path of our universe, we find ourselves at the start of everything, the Big Bang. This cosmic explosion set the stage for our universe's grand story, pumping out raw energy that eventually cooled and condensed into the galaxies, stars, and planets that we see today. It's this theory that best explains the origin and evolution of our universe, an idea that has been backed by strong observational evidence. From cosmic microwave background radiation to the movement of galaxies, the fingerprints of the Big Bang are evident across the cosmos. This theory paints a picture of a universe that began as a hot, dense point nearly 14 billion years ago, and has been expanding ever since. Yet the Big Bang is not the end of the story, but rather the beginning. It's the opening chapter to a tale that involves the formation of galaxies and stars, the creation of elements, and the birth of planets. And it's a story that's still being written today as new stars are born and old ones die, recycling their materials back into the cosmos. The field of cosmology is dedicated to unraveling this grand narrative. Through the eyes of powerful telescopes, scientists peer back in time, studying distant galaxies and stars to learn more about our universe's past and predict its future. It's an ongoing endeavor, a quest that's far from complete. Despite the strides we've made, there are still many mysteries left to solve. Questions about dark matter, dark energy, and the fate of the universe remain unanswered. Yet, it's these unanswered questions, these cosmic mysteries, that drive our curiosity and inspire our sense of wonder. While we've come a long way in understanding our universe's origins, there's still much to learn. But isn't that what makes the universe so fascinating?